Well, now in one previous video, I introduced you to the concept of exponents, the basic concepts, but I started with some basic identities. So in this video, it will be a quick reminder of these identities. Then after that, we will move on to the laws of exponents. The laws of what? The laws of exponents. So first thing first, identities. These are like basic definitions that we need in order to have these laws, smoothly applied. And what are some of the identities? Well, one of the identities is that any number written with a power 1 or an exponent 1 can be written as that number without an exponent, okay? So you can think of any number like 2 power 1 or 2 exponent 1. 2 exponent 1 is 2. 5 exponent 1 is 5. 8 exponent 1 is 8. 10 exponent 1 is 10. 250 exponent 1 is 250. Now notice that the reverse is true, meaning sometimes instead of writing a number, we would like to write it with an exponent of 1, depending on exactly the kind of calculation we are dealing with. So for example, 5 is the same as 5 with exponent 1. 8 is the same as 8 with exponent 1, like that, like that, like that. Then the second identity is that any number with exponent 0 gets to be reduced to 1. Any number with exponent 0 equals 1. So you can think of any number or any letter, okay? You could think of 5, you could think of 3. So 3 exponent 0 is 1. 10,000 exponent 0 is 1. X exponent 0 is 1. 335 exponent 1 exponent 0 is 1. Any number with exponent 0 becomes 1 or it's equal to 1. Now the other thing here is the reverse also works. For example, there are times when we want to write 1, the number 1, okay? There are times when we want to write this number 1. In fact, let me put it inside the bracket. We can also write the number 1 as any number, which in this case is a, for example, with exponent what? With exponent 0. Just like what we were going to have here, that this can also be written as any number equals to that same number with exponent of what? With exponent of 1. And so the third identity is that a number with a negative exponent, any number, okay? You can think of any number with a negative exponent can be written as can be written with a positive exponent. Notice the differences here. This time n is positive. Here n was negative. So this time n is positive, but it's now under a reciprocal. So very much like any number with a negative exponent, we can write it as a reciprocal with a positive exponent. Now this will make a lot of sense for the for the series of questions which we are going to be dealing with. But before we move to those questions, well, how else can we revise the reverse of this? Well, the reverse of this can be written as a number with a positive, a reciprocal of any number with a positive exponent can be written as that number with a negative exponent, like that, okay? So what is inside the bracket is used to indicate the reverse of what we have just been explaining, because the reverse is true. Now, we basically looked at one law last time. And so this time we can look at one more law, also known as the laws of exponents. So the first one that we looked at was that when it's time to multiply numbers that are the same in base, then the exponent can be added. Okay, so you can think of any number like 2 times 2. We know that 2 times 2 is what? 2 square. 3 times 3, 3 square. 4 times 4, 4 square. 5 times 5, 5 square. Why is it square? It's because right from 2, 2 times 2 means we have 2, then we add the power, you know, like 1 plus 1. So very much like, here we go, 2 times 2. Let me just create it down here. So we are having 2 times what? Times 2. That is what I was saying, 2 times 2. Well, what do we get from that? We get 4, or 2 squared. We know that it is 2 squared. Why is it a 2 square? Well, let me first put it here, a 2 with a square right up there. Why is it a 2 with a square? It is because this 2, which is the same as a, can be written as a 2 with exponent 1. You see? Then now, this second 2, also the same as a, can be written as a with exponent 1. So this 2 can be written as a 2 with exponent what? 1. And that therefore means before we even reach 2 square, what we can do is we put a 2 where we add the exponents. And so when we add the exponent, what are we going to have? Well, we are going to be having a 1 and a 2, a 1, giving us a 2 squared. So this is what we saw the other time, and we did that with a number of questions that we discussed. Now, the next thing that we want to look at is this second law of exponents. What does it say? Well, this second law of exponents states that if you have, okay, if you do have to divide two numbers that are the same in base, if the exponents are different, then you can subtract the exponents. You know what this means? Well, in a very short way, just a quick one before we look at, multitudes of questions. If you have, for example, let's say you're dividing the same number and this number is a 3 and a 3. Okay, now let's say the exponents are different. Now we would like to think that the exponent of the numerator is bigger than the exponent of the denominator, maybe 5, and the exponent of the denominator may be 2. So this law allows us to simplify this expression as a 3 with exponent of 5 minus 2. So this is what we get. And now to simplify that, we go ahead and we get a 3 with exponent 3. Yes, that is what we get. We could go ahead to simplify that, but sometimes we are supposed to leave our answer in what? In exponent form. And so if we are required to leave our answer in exponent form, that is where it stays. Okay? Now, we want now to look at, some more practice questions. And so, there we go. Let's now create the ground for playing. Remember these two rules or the laws of exponents. It's what we are going to be using plus the identities. So let's get into that really quick. So we will be moving to the first to the first question. One at a time. Well, What's the first question here? The first question is question 1. Question 1 has got so many parts. There are 12 parts. So we will do, this is A, B, sorry. All right. Okay, so there we go. We'll be having A, B, A, B, A, B, A. Yes, that's what we have. What do we do with it? Well, we are supposed to represent the following expressions in exponential form. Okay, so how do we do that? Well, we will be getting to it right away. Let's then look at the second question. The second question is having a 5 times a 5 times a 5 times a 5, 4. Then, then we have times x, x, x times y, 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 x, Oh, all right, this wasn't y. We have y, 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 x, y, x, yes. Now, this is part B. How do we get to that? All right, we will be coming shortly to it. Then we have got C, and C is C is A, B, C, A, D, B. Then D, C, A, B, D, C, A, B. Yes. We are supposed to write it with exponents. All right. Let's first write D. D in this case is, all right, let's see. We have X, 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 then Y, 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 then X, then Y, then X, then Y, then X, then 2 times 2 times 2 times 3 times 3 times 3 times 2. Yes, this is what we have. Okay, now I'm going to write up to F. So E is going to be 7 times 7 times 2 times 2 times 2 times 2 times x times x times x times x times x. Yes, 5. Then we will go to what? We will go to F. F is a little bit different. Yes, we have F there. Well, let's put it down. So this is going to be 11 times 11 times A. There we go. It's now a fraction there. So we got A divided by B. Yes. Now, I would like to include I because, all right, sorry, we have got 4 A's. Next to that 4. Right. Okay, so I'm going to include I. Why? Because it's using the second rule, and we had not seen anything about the second rule. Mainly, most of the questions are on the first rule. So let me write I right away. Let me write I. And so, what is I? Well, I is a fraction, and this fraction is having how many? 6 axes. 1, 2, 3, 4, 5, 6. Then 4y is 1, 2, 3, 4. Yes. Now, the thing here is we want to find a way of writing them with exponents, like the way we have been writing these things here, you know, with exponents, with this m, n, 1, 1, n, you know, 5, 3, 2, like that. So how do we handle this? Well, let me create some more space here. Creating some more space. Okay, there we go. Now, notice that the first step is to write all this with exponents of 1. Okay? So let's write all this, each with exponent of 1. So each with exponent of 1 will give us A with exponent of 1. Then B with exponent of 1 right here. B with exponent of 1. Then C with exponent. Okay, we could avoid that. We already know each of them, you know. We could write a number. Yes, let's just not write it. It's going to make this whole task so long for nothing. So let's just go ahead. We put them instead. So we want to have A with A and B with B. So we start with A. How many A's do we have? 1, 2, 3, 4, 5, 6. So we get it. 1, 2, 3, 4, 5, 6. Then how many B's? 1, 2, 3. Yes. So there are 3 B's. 1, 2, 3. We got that. So now in the next step, it's going to be easy for us because we know each A has got what? Has got exponent of 1. So we now have 1, 2, 3, 4, 5, 6 A's. So we would like to write A with exponent 6. Okay, A with exponent what? With exponent 6. Because there are 6 A's. Then now B with exponent 3. So we get to B with exponent 3. Like that. This is how we write these numbers in exponential form. We could have added, you know, we'd be like, well, 1, 2, 3, okay, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Okay, we would still get that. Maybe we can include that right away. So let's include it 1, 2, 3, 4, 5, 6. So we'd be like, well, 1 plus 1 plus, oh, the first one should have been plus, this should be plus, yes. Okay, so we move to a 1, then plus 1 plus 1 plus, how many so far? Let's put one more. So 1, 2, 3, 4, 5, 6, yes. Then now a B with how many ones? 3 on top. So we'll be like, let's have B with the exponent 1 plus 1 plus 1. Okay? So 1 plus 1 plus 1. Okay, because there are 3 B's there. That's what we get. Now, in the next question, it's going to be a lot easier for us to see things. Now, the good news is these first 5s have already been grouped. And so we just don't need to spend time doing anything else. So the first 5 have already been grouped. Then now we look for x. We have 1, 2, 3, 4, 5x. So we say time, there are 5 x's, 1, 2, 3, 4, 5. Then how many y's do you have? 1, 2, 3, 4. We have 4 y's. So this will be 1, 2, 3, 4. We have grouped them. Now, after grouping them, we now want to count the numbers there because each number represents each power. So 1, 2, 3, 4. So it will be 5 with exponent of what? Of 4. Yes. Then now the next is to do what? Is to have x. X has got how many exponents? 1, 2, 3, 4, 5. So x will be having exponent of 5. Then we move to what? We move to y. So y has got how many exponents? Well, 1, 2, 3, 4. So we say y with exponent 4. And this becomes our answer. Now, the next question is what? Is C. First step to group. Well, we want to see what the letters there. We start with A, 1, 2, 3. Well, there are 3 A's. So it will be like 1, 2, 3. Then how many B's are there? 1, 2, 3. Okay. 3 B's. So we'll be having B, B, B. How many C's are there? 1, 2. 1, 2. How many D's are there? Also 2. 1, 2. Yes. Now that we are done with the grouping, the next step is to what? To indicate the exponent. So how many A's are there? Well, 1, 2, 3. So we say this is A with exponent of 3. Then the next is B. B, 1, 2, 3. So we say B with exponent what? Of 3 right away. Then how many C's we count? 1, 2. Well, there are 2 C's. So we say C with exponent what? 2. Oh, all right, sorry. This is not how it's supposed to be. C here with exponent 2. Well, the next number there being D. So how many D's are there? Well, we count 1, 2. So D will be having exponent of 2. Well, we can now go ahead to look for D. That is question 1, part D. So we also group. It's better always to start with the numbers before we go to letters. So we start with the 1, 2, 3, 4. There are 4 twos. So it'll be like 1, 2, 3, 4. Then how many threes are there? 1, 2, 3. 3 threes. Okay. So we'll be like 1, 2, 3. Then after that, we want to look at the x's and the y's. So how many x's are there? Well, let me first remove this. 1, 2, 3, 4, 5, 6. So there are 6 x's. So it will be like 1, 2, 3, 4, 5, 6. Then how many y's do we have? Well, 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. Yes. Now the next step after grouping is to count and indicate the exponent. So we start with a 2. 2 has got how many appearances? 1, 2, 3, 4. Oh, there are 4. So we say this is 2 with exponent 4. Then we have a 3, and a 3. So 3 appears 3 times. That means 3 has got exponent of a 3. Then the next thing is x. X has got how many appearances? 1, 2, 3, 4, 5, 6. So we got x with exponent of 6. All right. Then now we move to y. Well, we count 1, 2, 3, 4, 5. Y has got 5 appearances. So it will be y with exponent 5. All right. After that, we now move to 7 and a 2. They're already grouped. So we don't need this middle step. We just go right away to writing the final answer. 7 has got how many appearances? 2. 2 has got how many appearances? Well, 1, 2, 3, 4. Yes. 2 has got 4 appearances. What else do we have? X. Let's count 1, 2, 3, 4, 5. X has got how many appearances? Well, X has got 5 appearances. Yes, that's how we would do F. Now, next. Okay, so we now want to look at these two. Well, Eleven has got how many appearances? Notice they're already grouped. So it will be like 1, 2. That's 11. 11 has got 2 appearances. So we have 11 with the exponent 2. What else do we have? We have A. All right. Now we can write it as fraction again. A has got how many appearances? 1, 2, 3, 4. So we say A has got 4 appearances. All right. So it's going to be better we write like this. No, it's not accepting. All right, so let me first put this, then that. All right, so now we should say A has got 4 appearances. That means the exponent is 4. Then B has got how many appearances? Well, B has got, okay, 1, 2, 3 appearances. So B will have exponent 3. Okay, now, well, this is what we got. This is going to be the solution to the question we selected. Well, how about I? Okay, notice that G and H plus the question which follows are for your activity. So please make sure you write them down, and then we do what? You write them down and you do them. They are here. Yes, they are right here. Okay, so we now want to move to I. Well, let's close that. Now, I, we write this as, let's have the fraction in place right here. Now, let's count how many appearances do we have for x? So we count 1, 2, 3, 4, 5, 6. All right. Maybe before we write the appearances, let's change the pattern of the letter to what we can easily recognize, which is this. That is called italic. So we want to write x with appearances. How many? 1, 2, 3, 4, 5, 6. Yes. X has got 6 appearances, and so the exponent will be 6. And now the next is what? Is y. 1, 2, 3, 4. So we say y has got 4 appearances. So this will be y with exponent 4. Okay. So now, let me see. We are done with I. Yes, that's all. That's all for I. Well, maybe really quick on question 2. How many parts do we have for question 2? Let's see. For question 2, we have 6 parts, yes. So, let me do 3, and you do? No, there are 9. So I will do 3, you do 6. Or I do 6, you do 3. So let's see how it comes. We start by doing what? Writing the question down. This is question 2 about expansion. We have to expand. Okay? We write the opposite of what we have been doing. And so we say expansion. That is question 2. We are supposed to expand. And so we are calling it expansion. All right. No. This. So there we go. This is expansion. Why is it lowercase? All right, good. Same case. So which part start with the part A? Okay. Oh, no, not that. Yeah, there we go. So we start with part A. What are we doing in part A? Well, we have the expression. Well, let me first put B and C, D. Yes. Now, nothing here. I thought I'd written it. Then here. All right. There we go. Okay. All right, so part A, what do we have? Well, we have a 2 and 1x. The 2 has got exponent of 5. So we write a 2 with exponent of 5. Then we also have a 3 with rather 1x with exponent of a 3. So exponent 3. How do we expand this? Well, let's first write the next question. Really quick. Now the next question is B. And in B, what we want to do is to expand. What do we expand? We have a 5 multiplied with what? A 7. And this 7 is multiplied with 1a. Yes. All right. So when we are done with that, let's first fix this. The lettering is not the one we want. All right, there we go. So a C, really quick, a C. Well, a C this time will be this, a 3x and y. It's this, a 3x and y. Yes, 3x and y right away. Okay, so the 3 has got exponent 3. So 3 has got exponent of 3. Then this x has got exponent 2. So the x has got exponent 2. All right? And now we have a y. This y has got exponent of 4. All right. So we now move to D. Okay? Now, D is possibly the last we want to deal with. And so this will be 10 with exponent of 4. So this 10 has got exponent of 4. And then the next is what? X, y with exponent 2. So we got x. That's this x. Let's change. So we got x. Okay. Then we also got y, rather x with the exponent what? X with the exponent none, rather 1. Then a y with exponent 2. Okay, we got there a y with exponent 2. Then later a z or z with exponent 3. Yes. So that's what we got. Now, let's expand the playground. All right. So we are expanding. And so, what are we going to have here? Well, x is appearing, rather 2 is appearing 5 times. And so 2 for the first time, 2 for the second time, okay, 2 for the third time, 2 for the fourth time, 2 for the fifth time. Then x is appearing 3 times, okay? We have x, x, x. Yes, that is what we're going to have as the answer for the first one. That is, now we have expanded it. Then the second question is asking us to expand. Oh, wait. We did not write the exponent. That is B. Let's see. Yeah, we did not. And so let's put the exponent right here. So 5 has got exponent of what? Of 2. Right there. Then what do we know about 7? 7 has got exponent of 4. So we write it right away. 7 has got exponent of 4. Then A. A has got exponent 8. All right. We put it right away. Say A has got exponent what? 8. Yes. That's what we got. Now, we begin to do what? To simplify. We start with 5. 5 appears how many times? 2 times. So we have a 5 and a 5. Okay. Times, we can use multiplication, which they have chosen, or a dot. Let's use this multiplication. 7 is appearing how many times? 4 times. So we have a 7, then another one, the last one, 4 times. Then we can go ahead to use this multiplication sign. We now want to deal with 8. And so we say, rather A, not 8. We say A is appearing how many times? 8 times. So we have it 1, 2, 3, 4, 5, 6, 7, 8. Yes, let me expand about the playground right here. Okay. Expanding the playground. Right. Okay. That's what we got. Then we go to question. The next question. Yes. See. 3 is appearing 3 times. So we get 3, 3, 3. X 2 times. Then we got X, Y 4 times. Then we got 1, 2, 3, 4 for Y. Yes, that's how we would do what? We would get it. Well, just put a multiplication there. All right. Then now, the next thing we want to deal with is to simplify the last question, which is, okay, the last question, 10 appearing 4 times. So we want to write 10 for the first time, 10 for the second time, 10 for the third time, 10 for the fourth time. Yes, makes sense. Then now we have X. X is appearing once. Then we have Y appearing twice. So once, twice. Then we have a Z appearing 3 times. So once, twice, 3 times. So this is how we simplify. Okay, this is how we simplify the questions given in the name of expansion. And so once again, let me reduce this so that you can check the question right away. So please go ahead and solve the questions which are remaining. The question starting with E, F, G, H, and I. And when you are done, make an effort to reach me with the answer. for correction. Otherwise, this has been Exponent.